So, Mr. Clemenger and I, in our very first year of teaching this class, realized that we had a gap in what was taught. We were taught this stuff in geometry, and then there was nothing about it in Algebra 2. And then we expected, our book even expected, that we would remember this stuff and know it and be able to just run with it come pre-calculus. So, we're going to supplement our curriculum a little bit and talk about circles today. So circles is part of an introduction to conics. And when you hear the word conic, what word comes to mind? Cone, right? Okay. So a cone is, we can all picture a cone. I don't have one in my hand, right? We picture a cone like a funnel, right? And if we slice a cone off perpendicular to the cone, we're going to get a circle. Okay? So that's one of our conics, and we'll talk more about the conics later on. So first of all, this particular circle has two things that we need to know in order to be able to determine its equation. One of them is the center of the circle, and the other one is the radius of the circle. Okay? So this one has a circle that is centered at what?
0, 0.
0, 0, the origin. Okay? So we've got a center at 0, 0. How long is its radius?
5.
5. How do you know?
Average between 4 and 5. You just count 5.
So this is 4, and this is 3, and 3 squared plus 4 squared is 5 squared. So 3, 4, 5 right triangle. Okay? Yeah, it goes from 5, 0, 0, 5, negative 5, 0, and 0, negative 5. So every point on that circle is 5 units away from its center. Okay? So far, so good? Okay? So, doesn't matter what point I use now. Let's pick this point. And I drop a perpendicular down. This guy we said was 5 everywhere, right? How far is this distance?
4.
In general.
Square root.
It's 3 points, negative 3 point something, right? For that point. But in general, what am I doing when I'm moving to the left? What's moved? Versus what is this? This is the y, right? For any point xy that's on that circle, that's the y, this is the x. So, how would I find that equation in general?
Square root of both those terms squared.
Yes, so my horizontal movement squared plus my vertical movement squared should be equal to my radius squared. Make sense? Remember this equation? Looks a lot like Pythagorean Theorem. X squared plus y squared equals r squared. Or a squared plus b squared equals c squared, but x squared plus y squared equals r squared. Okay? You see the connection, right? All right, questions on this so far? So then, let's change it up. Let's move things around a little bit. Okay? This one has a new center, doesn't it? Yes, yours is different. I want to show you a little bit of another version of it. So now I've changed my center, haven't I? Everyone see that my center is now the point A instead of the origin? And this is the point 1, 2. Currently, what's the ordered pair up here for xy? 6, 6. Okay, so if this is 6, 6, then 6 minus 1 gives me my vertical distance, right? Or my horizontal, sorry. 6 minus, this is 6, 6? Yes. 6 minus 1 gives me 5. And 6 minus 2 gets me 4. And 5 squared plus 4 squared is 36 plus 25. Sorry, 16, 36 plus 6. 5 squared plus 4 squared. I'm thinking of something else. 25 plus 16, which is 41. Okay? Now, watch what happens as I move this point.
Oh my God.
Can stretch it out, bring it in, right? Here's my new point. I'm at 3, 9 now. The distance between the x's, right? The change of an x, the change in y, squared each gets me my r squared. 49 plus 4 is 53. So far, so good? If I move my A, my center, get all kinds of other great stuff that happens, right? And now what has changed? What I'm subtracting from y and x, isn't it? All right, so far, so good. So what I'm trying to get to for you is the new equations of things. What's the center of this guy? 3, 2. What's the radius of it? 4. What will the equation of this guy say? If it was 0, 0, it would be x squared plus y squared is 4 squared, right? But it's going to be x minus 3 squared plus y minus 2 squared equals 16. Okay? Why is it not y plus 2 and why is it not x plus 3? Okay, great question. Okay? Let's go take a peek. Grab this guy.
You ever just have a really big headache? I got a big one.
All right, so right now we're centered at 0, 0, right? If I move this slider, I get a bigger circle or a smaller circle. I'm changing my R. So far, so good? Okay. Watch what happens when I move my horizontal movement, my x. Right now, x is 0. Watch what happens if I move it to the right. What's happening to the equation?
It's growing larger because that's how many spaces you need to move back to get back to 0, 0.
Good. So it's the distance between it and 0, 0, isn't it? It's 10 away. Okay? So when I moved it to the right, it became x minus 10. When I move it to the left, what's happening? It's plus, right? So it's the distance between it and 0 is what's going on with the horizontal movement. Okay? Let's put it back at 0. What happens if I move up? Minus, right? And when I move down, it's plus. Okay? Which kind of makes sense, right?
Yeah.
Because when we had an equation of a parabola in the past, y equals x minus 5 squared plus 3. What was the vertex of that parabola? 5, 3. The opposite sign of this guy, wasn't it? Because it was with the x. So to get it separated from the x, it would have to go to the other side of the equation, wouldn't it? That make sense? Okay. So back to my original. The standard form of an equation with a center at hk is x minus h quantity squared plus y minus k quantity squared equals r squared. So x opposite sign of h squared plus y opposite sign of k squared equals r squared. Make sense?
H,
Guys, remember this equation from
H can just stand for horizontal
horizontal shift.
which is just how far left or right it moves at
Absolutely.
0. And
Absolutely.
then
K is your vertical
oh, okay. That's how you spell it.
shift. you're Russian, right?
Yeah, if you're
You're vertical.
Chicago.
Okay, make sense? All right. So, now if I give you a center and a radius,
We can solve.
can you write the equation of it? Standard form. So what's it going to look like?
X minus 2 squared plus y plus 1 squared equals 6 squared, which is 36.
Very nice. Switch the signs of your center, right? Still looks like the Pythagorean theorem to me, right? With a slight change. You just moved it left or right, up or down. Questions on that one? Okay, next one. Now I want a circle in standard form with a center of 3, negative 4 that passes through the point 6, 12. So it looks similar to the last question we had, right? Yeah, let's start with the x minus 3.
Squared
Uh-huh.
plus parentheses y plus 4 squared equals. That's 8.
And now we've got to find r. How are we going to find the radius?
It should be 68. Wait.
We're going to take a 6.
So the square root of 180.
6 minus.
Oh, I did that wrong.
36 minus 3 and negative 12 plus 4.
It should be 8 squared. It should be
Okay.
2 squared plus 8 squared equals your
Oh, yes, thank you. Your equation has a negative 12, doesn't it?
Yeah.
I'm sorry, my apologies. I should have changed that.
That's what I got to.
Okay? All right, so slight problem here. Now we know the center, and we know a point on the center, right? Or on the circle. So we know what the center is, and we know a point that's on it. How are we going to find the radius?
Subtract and find the 2 legs of the triangle, and then you do the Pythagorean theorem.
So we could use the Pythagorean theorem, right? Or, what other tool do we have at our disposal? The distance formula. The distance formula, right? Given 2 points, we need to find the distance between them to know what the radius is, right?
More complex.
It's not more complex. It's right there.
Oh, isn't it the y minus
Yeah.
y2 minus y1 over?
It's right there.
Oh.
Oh.
Oh. So it's the square root of 73.
Danny.
That's
Oh.
what I was saying. I was saying 6 minus 3.
Yeah, that's what I did the whole time. Okay.
It's been there all these years. You've been on the distance formula for what? At least 4 years, right?
I don't know.
Algebra 1. You've been using the equation of a circle for 4 years.
Wait, so the answer is the square root of 73.
So, this is our x and this is our y, right? One point that happens to be on the circle of literally an infinite number of points, right?
Replace the 6 with the x and the
Yeah.
y with the negative 12. Which is square root of 73 on infinite time, like 17.
That's, well, negative 12 plus 4. But it's r now, right? Instead of d. What's 6 minus 3? 3 squared. What is 12? Negative 12 plus 4? Negative 8 squared.
64.
So those of you who said that it was a square root of 73 were spot on. Good job, right? Square root of 73.
Square root of 73 is something.
So now to write our equation, we're back to this again, right? X minus 3 squared plus y plus 4 squared equals, we need to simplify square root of 73?
Can't you get rid of all the squared symbols?
Yeah, get rid of the square roots. We're squaring R anyway,
You just
right?
get 73.
So 73.
Wait, would you get rid of the twos?
Do we just get rid of the 2's?
The squares, because remember to get rid of the radical symbol
So we're trying to get rid of the radical symbol, so we're
on the
going
right hand
to,
side of the equal sign.
so we're going to square both sides, right?
Oh, gotcha. Never mind.
Make sense?
That's standard form.
That's standard form of an equation, of a circle. Questions on this one?
Wait.
Suddenly distance formula doesn't seem so hard, right?
Oh, yeah, I get it.
Okay?
Probably just be okay.
Wait, so
Uh-huh.
why isn't the square root of 73?
Okay?
Wouldn't the square root of 73 be the base?
Because remember that x minus r, or minus h squared, plus y minus
Oh,
k
because it's already squared. Got it.
squared, yep, equals r squared, isn't it?
Oh, so we can find answer you leave squared.
You have to square your radius, yep.
Oh, okay.
Yes.
So you can't use Pythagorean Theorem?
Absolutely. You could
But
graph
when you do
it.
it, you get the square root of 180.
When we square a negative number, so did I make a mistake somewhere? 6 minus 3, right? 6 minus 3 is 3. 3 squared is 9. And y, so negative 12 minus 4, so it's going to be a plus 4, right? So negative 8 squared, it'll be 64. Where we make a mistake. Okay, so how would you do that? Remember, this is a negative 12 on your paper. So is that where I'm making a mistake?
How does that change it?
Okay.
Then you're squaring it.
So, but when we square a negative number, we're always going to be positive, right? So let's plug it in. So let's graph this. If we were at 3, negative 4. 1, 2, 3.
Oh, the center is at 3, negative 4.
Yep. So you're probably using it from the origin.
Yeah.
Yes.
Okay.
Yep. Center's at 3, negative 4, and our point on the circle is at 6, negative 12.
That makes sense.
So we've got this point.
Distance from 3, negative 4.
Yes. So if I could sketch it properly without making it look like a football or a ellipse, right? It's going to be something that looks like this, right? Okay? And this is the radius that we're looking for. Yeah. So you would have to use Pythagorean. You have to sketch it if you're not going to use distance formula. But see how much easier distance formula is? Yeah. Yeah. Make sense? All right. Next piece. So here's where your homework from last night will kick in. Okay? Because now we've got this equation, but it's not in standard form. So the center and the radius are not easily visible. See why standard form is kind of handy? We can immediately look at it, decide what the center was, and we can figure out what the radius was. So now we've got x squared plus y squared minus 8x plus 4y equals a negative 11. Suddenly this guy is all mixed up, right?
Yes.
Descending powers of x and y. Okay, but what happens if we do this? And we gather ye rosebuds while ye may. Let's put the x's together, leave a gap. Gather the y's together, leave a gap. We'll do that. What do you think we can do?
Solve it.
Complete the square. For 2 at the same time. So not only were we having to complete the square as something we should have learned last year, right? We reviewed and used this here, but now we get to do it twice on steroids.
Oh,
Okay, so not only do I magically make the distance formula appear from the equation of a circle today, but let's talk about the magic numbers that we want to use here, right? What's the magic number that we're adding?
16.
16, why?
Square root of 4.
8 divided by 2, right? Squared is
Wait, where do you get that 2 from?
Okay? Half the middle term squared.
Half the middle term squared.
Okay, but now it's not a middle term anymore, right? So half of the coefficient of x squared. Okay? So if I add 16 to this side, though,
Out to the other side.
gotta go way over here to the other side and add 16. Okay? Now what?
Half 4 is 2 squares 4.
Yes, so we're adding 4 as well.
You add 4 to the right side too.
Add 4 to the right side as well. Now I've got a perfect square trinomial here by design. We can write it as the binomial squared. What is it?
Y
X
plus
minus 4 squared plus y plus 2 squared equals 1.
Good. So what's the center?
positive 4, -2.
Wait, how did you measure the 16?
And the radius is 3, right?
Oh, that's right.
Yep.
That's from the square root thing. Okay.
Yep. Half the middle term squared.
Where'd you get the
Yep, add them all up. So a positive 5 and a positive 4 gets us a 9. So colors can help to kind of keep track of what I'm adding to both sides, and away we go. Questions on this one? One more.
Wait, that was it?
Let's do the last example. Make sure you got it down.
Wait, no. Like that was it?
Yeah, that was it for that one, because we had to find the center and the radius, right? And our center was for -2, and our radius is the square root of 9.
Oh, so you take the y, you take the y out then? Oh, you do the thing twice,
Yep.
okay.
Here's our h and here's our k.
Okay, so wait. If you get 2 non, oh, okay, I get it, that makes sense.
Good?
Okay. Yes, it does.
Would be x plus 5 squared and y plus 1 squared. 4. So your center's at -5, -1. Radius is 2.
Good?
This is pretty easy.
Not too bad, right? All related to the Pythagorean Theorem, right? All related to the same things that we've been doing. If you shift it to the right, it's going to be negative within the parentheses. If you shift it up, it's going to be negative within the parentheses, and vice versa. The backside's your homework. And then we're going to do a little ACT prep. Okay? Yes, sir. 1 second.
Three on the back.
Number 3 on the back.